Hey folks, in this video we're going to be talking about a concept called limiting reactants. Push it to the limit. That's a song, you might not know it. Anyway, I want you to be able to explain what a limiting reactant is, and I want you to be explaining to me later in your life. My word's weird. I want you to be able to explain how limiting reactants apply to everyday life, and I would like you to be able to calculate which reactant in a chemical equation is the limiting reactant. So let's get going with that. Limiting reactants in life. Whenever you're doing like anything where you combine stuff, chemistry, cooking, building, or combining materials, you are always pretty much going to run out of one of the materials you are combining together first. One of those will be depleted first. The thing you run out of first is what we call the limiting reactant. Let's look at some examples. Let's say you're making some really weak sauce cheese sandwiches. Okay, you got 6 slices of bread and 4 slices of cheese. Okay, well this, based on our ratio, is enough to make 3 sandwiches based on the bread. 4 sandwiches based on the cheese. We're going to run out of bread before we run out of cheese. Bread is the limiting reactant here. Once we have made 3 sandwiches, we don't have any more bread. There's still more cheese, which we could theoretically make a sandwich with, but we can't because we've run out of bread. Bread has stopped the reaction where it was because we ran out. It is limiting how many sandwiches we can make. It is the limiting reactant. And here's that visually. If this is our recipe for a sad cheese sandwich, and we start putting together a sad cheese sandwiches, well, at the very end, we have just 1 piece of cheese left over. Bread has limited how many sandwiches we can make. It is the limiting reactant. Cool? Cool. Let's look at another example that's maybe a little bit more confusing. But if we want to make dough from water and flour, and like, let's say we're going to be using a ratio of 5:3, based on this, I could be making... Which one am I going to run out of first? Well, I'm going to use up this flour first. I can use 5:3, or if I put in all of my flour, that's going to give me 4 to 6.67. Once I've used up all of my flour, or to use all of my flour, I would only need 6.67 cups of water. And I've got way more than 6.67 cups of water. So I will have water left over once I've used up all of my flour. Flour is the limiting reactant. Whichever one of our reactants or things we're combining runs out first, that is the limiting one. And so after this, if I've used all of my flour, I should have 3.33 cups of water remaining. That would be my excess. We'll talk more about the excess in another video. So limiting reactants in chemistry. Limiting reactants are going to be calculated using stoichiometry. Gosh, I love stoichiometry. So for each reactant, we're going to determine how much product can be made. Whichever reactant is going to make less product, that one is limiting. Just like if I looked at those other examples, my cheese made more sandwiches. I'm sorry, my bread made less sandwiches, so it was limiting. My flour made less dough, so it was the limiting one. Once you've determined which is the limiting reactant, I recommend you circle it in your chemical equation or somehow note otherwise. This dude is limiting because you are going to base the rest of your calculations off of your limiting reactant. So let's look at a simple example. I got 25 moles of oxygen, and I'm combining it with 33 moles of hydrogen gas. According to this balanced equation, which chemical is limiting? So let's go through this together. What I'm going to do is, for each reactant, I'm going to determine how much product can be made. And then I'm going to look which one makes less product. So I'll pull up my roadmap, and for each of these guys, I've already got moles of O2 and moles of H2. So I'm just going to use my balanced chemical equation to convert both of those to moles of product. Neat. Let's make that happen. So I'll start with the hydrogen. I'll do my dimensional analysis. So 33 moles of hydrogen times, I'm going to need a fraction here to get rid of this, and I'll use my coefficients. So 2 moles of hydrogen gives me 2 moles of oxygen. Boom. Gives me 33 oxygen. Water. 33 moles of hydrogen will allow me to produce 33 moles of water. Okay, and I'll do the same thing for my oxygen. I've got 25 moles of oxygen. I'll use my balanced chemical equation and say, all right, well, we produce 2 moles of water for every 1 mole of oxygen. 25 moles of oxygen should make 50 moles of water. So which one of these is the limiting reactant? Think about that for a second. Great. Well, if we check, hydrogen is going to make less of the product. Whichever reactant makes less product is limiting. Therefore, hydrogen is our limiting reactant. So I'm going to circle that dude and say the most water we could make combining these two is 33 moles. Neat. Let's look at a slightly more spicy example. Why don't you pause the video, pull out your stoichiometry roadmap, and see if you can solve this dude on your own. Give it a shot. Cool. Well, you gave that a shot. Let's talk about it together. For either of these, I'm going to need to convert my 45 grams of lithium into product, and I'm going to convert my 56 grams of oxygen into product, and we'll see how this goes. So I'll pull up my stoichiometry roadmap to help me figure this out. For lithium, I'm going to be starting with my mass of lithium. It's going to be 2 steps. I'll convert to moles of lithium, and then I will convert from moles of lithium to moles of product, and I can just leave it off there because I just want to know how much product we can make. And so my conversion factors, I'll need the molar mass of lithium, boom, and I'll also need my coefficients from that balanced chemical equation. Well, I know 4 lithiums is going to be equivalent to 2 moles of product. Great. And I can also look at oxygen and say, all right, well, I'm also starting with grams of oxygen, so I'll convert to the molar mass, or using the molar mass, I'll convert to moles of oxygen. And then I will similarly convert from moles of oxygen to moles of this product, lithium oxide. So the conversion factors I will need will be the molar mass of oxygen, or O2. And then again, I'll look at my balanced chemical equation for my coefficients and say 1 mole of oxygen is equal to 2 moles of lithium oxide. Neat. So I got a whole plan that I've made using my stoichiometry roadmap, and now I can just make it happen. So yeah, let's do the stoichiometry, or rather the conversions. So I'll start with my 45 grams of lithium. I'm going to multiply this for my first step by this dude as a conversion factor, and then by this dude. So let's set up that first conversion factor. We want to get rid of grams, so we'll put grams down below and moles up top. And then for our second conversion factor, we want to change from moles of lithium to moles of lithium oxide, so we'll put moles of lithium down below, and our new units, moles of lithium oxide, up top. Neat. And so we can multiply through and solve for moles of lithium oxide. And I'll do the same thing for oxygen. I'll start with my mass of oxygen. I'll use my molar mass to change these grams into moles of oxygen. And then I will use my conversion factor from the balanced chemical equation to convert moles of oxygen to moles of lithium oxide. And now I can just multiply through 56 divided by 32 times 2, and that gives me 3.5 moles of lithium oxide. So based on this, which one of these is the limiting reactant? Pause the video and think about that for a second. Yeah, you're right. It is the one that produces the least products. So lithium is going to be the limiting reactant. Based on the amount of lithium, we can only make 3.4 or 3.242 moles of product, not this full 3.5. So I will circle lithium in my reaction and say this dude is the limiting reactant. Let's try maybe one more spicy example problem. Why don't you pause the video up on this dude and see if you can tackle this yourself. Poof. All right, well, you paused it. Let's talk about it together. I'm going to pull up my stoichiometry roadmap and similarly come up with a plan. Let's see. I need to convert my grams of nitrogen to product. And I'm also going to need to convert my liters of hydrogen to product. Let's start with the nitrogen. If I'm in grams, I will do it in 3 steps. Oh, you know what? I want to know how many grams of product there are. Grams of this dude. So we'll go from our mass of nitrogen to our moles of nitrogen to our moles of product, and then finally to our mass of the product. So grams of nitrogen to moles, moles of nitrogen to moles of ammonia, and moles of ammonia to grams of ammonia. It'll be 3 steps. I'll need the molar mass of nitrogen, the balanced chemical equation for my coefficients, and also the molar mass of ammonia, NH3. And it's going to be a similar process for hydrogen, right? Except for hydrogen, we're starting in liters. So first, we will need to convert our liters to moles, and then same process, moles to moles, and then moles to mass. So the only difference here is we will need a different conversion factor to change to moles of hydrogen, and a different conversion factor to convert from moles of hydrogen to that moles of product. But otherwise, same molar mass for that last step. Okay, so let's make this happen, and we can figure out which one of these will produce less product. So, starting out with our nitrogen, it's going to be 3 steps, so I'll start with the number that I know, and first I'll convert those grams to moles. I'll use my first conversion factor, putting grams, the units to be canceled, in the denominator. I'll use my second conversion factor. We want to change from N2, so I'll put N2 in the denominator and moles of product in the numerator. And then lastly, I want to convert from moles of product to mass of product, so I'll put my moles of product in the denominator. And now I can multiply through and figure out how many grams of product can be made from this much nitrogen. Cool. Well, I'll do the same process for hydrogen, except using the correct conversion factors. So first I'll use that 22.4 liters to get rid of my units of liters and change the moles. Then I'll use that balanced chemical equation to change from moles of hydrogen to moles of ammonia. And then lastly, I will again change from moles of ammonia to the mass of ammonia. So I can see based on this that my hydrogen makes a very, very small amount of ammonia. So which one of these is the limiting reactant? That's right, it's the hydrogen, because hydrogen makes less product. So I will circle that as the amount of NH3 that can be produced. And I will also say that hydrogen is my limiting reactant because there's so little hydrogen, we can only make approximately 20 grams of ammonia gas. Sweet. Well, that's the end of this video. I hope you feel like you understand why stoichiometry might be used, and more importantly, are able to perform stoichiometry calculations, particularly using the aid of that stoichiometry roadmap. Ta-ta, and have a great rest of your life.